Okay, let's look at the question number 2 here. Okay, this one, number 2. This question they're talking about find the derivative of the inverse sine 1 over x, right? So this one we need to remember. We need to use the formula, the basic formula for the inverse sine functions like this. So you have like a du. No, you're gonna have like this one here. You have d sine inverse function of u du. Okay, this one will be equals to 1 over square root 1 minus u squared. That's the basic function formula we're going to use. This is the inverse function derivative. Okay, so how can we use this one to this question? So we can see that here u will be, this part will be the u, right? So, and then we have this one because here we do the dx. So if this dx, it means u is the function of the x. So that means you have to go by du dx, okay? So this is the basic formula we are going to use. We're going to apply this one to here, okay? Now, first thing we think that this function will be what? Inverse function u. And the u equals 1 over x, like this, right? Okay, first thing first, we do derivative of the u here, we got this one. So we will get 1 over square root 1 minus u squared. And then you do du dx. Du dx here will be, see here, du dx will be equals what? Negative 1 over x squared, right? So we plug in here. So this one times by negative 1 over x squared, like this, right? And then we will get, and substitute the u back, because u equals 1 over x. So we substitute back. So we're going to have 1 over square root 1 minus 1 over x squared, and times by negative 1 over x squared, like this, right? And then from here, we can further simplify, right? We further simplify this negative 1 over this one, right? And when you have this one, you can go by like this. This bottom one you can change to 1 minus 1 over x squared, like this. And then this one, you time by x squared outside, like this. And then this one is over 1. You can time by x squared, time by x squared, like this. So you will get, and you take the denominator x squared out. Okay, I go step by step. So you go negative 1 over square root x squared minus 1 over x squared. But you have outside, you have x squared there, okay? So now I'm keep going to this one again. I put it here, okay? So I will get negative 1 over this x squared can be out as absolute value. This one can be out as 1 over absolute value of x. Because make sure every number take out of the radical sign should be positive. We don't know x is positive or negative yet, so that's why we have to take it out as absolute value there, okay? And then here you have what? X squared minus 1. And then you time this one out here. This one is x squared, like this. And then you continue, negative 1 over this one together will be just the absolute value of the x. You cancel the x, so it makes it only one x, but make sure it's positive, so put the absolute value there, okay? And then square root x squared minus 1. So this is what we got here for this question number 2, okay? Generally, what we did was like this. We used this formula, d sine inverse function u dx equals 1 over square root 1 minus u squared times by u du dx. That's the formula we're going to use. And then just to keep in mind, u will be the 1 over x. So du dx will be this, okay? Like this. And then plug in. So this is du dx. And this part is d inverse sine u du is this. And then substitute back by u equals 1 over x. Put it back. The rest of them just simplify. But the only thing here is this. Here you have x squared. Here, this is x squared. So you put it out, it's 1 over, here like this, 1 over absolute value of the x, because any value out of the radical sign, even roots, right? Second roots. So it must be positive. So that's why you have the absolute. To make sure x is positive, because we don't know x is positive or negative or not. So make sure we put the absolute value there, okay? Now, we'll continue to go to question number 4 now, okay? When we do the question number 4, let me just erase this part first. Okay, we go to question number 4. Number 4, we move up a little bit here. This one, right? Now, when we do number 4, the basic formula we need to use is this. We knew here. We knew the derivative secant inverse function x. This one equals what? 1 over absolute value of x square root x squared minus 1. Okay, that's the basic thing. So from there we can see secant x inverse function of the x plus c, of course the constant, equals to integration 1 over 1, this is 1 over this is dx, and absolute value of x square root x squared minus 1. Okay? Of course, if you remember this integration formula is fine. Or you remember the differential equation is fine. Formula is fine. But you can change it. So when you look at this one here, this one's dx, and the absolute value of x, and square root x squared minus 1, right? But this is minus 1. This is what? Minus pi. So we can do something to change it, okay? So when we do this part here, I put the work from here, okay? Now, what I'm going to do is this. This one, first thing first, I'm going to do is simplify this one to 1 to be similar, to be same as here. Instead of the pi is 1, okay? So what I'm going to do is just do some algebra transformation, right? So what I'm going to do is this. I put dx here over, right? This is integration, integration. And then I'm going to put, this is the x still there, and the square root is x squared, right? You go like this here. So you go from here, you can take the pi out under the square root. After you take the pi out, you have what? x squared minus over pi minus 1 like this. See that? See, I'm doing this kind of changes here. This is 1 now, this is 1 now here, right? Got it? Now, further simplify, okay? So I'm going to do is, I take a square root of pi out. So you're gonna have what? This is dx. You have a square root of pi times x like this. And then parenthesis under the square root. Okay? You have x squared. No, this is not x squared here. So you will get, I can write like this. I can write it as x over square root pi and the squared like this, and minus 1 like this. You see here? X squared is x squared here, match. Square root pi squared is still pi here, okay? And I got like this. So now, looks like here, the variable here should be the same. Here must be what? Same as x over square root pi, right? So what I'm going to do is this. I'm going to times square root pi here and divide by square root pi here, like this. Okay? Like this. So this part I can change it to d x over square root pi, like this. But I have to time by this square root pi in front of that. Okay? And then the bottom one is x square root pi. And then square root x over square root pi here. And the square root minus 1 integration like this, right? So original question, I changed to the format like this. Very, very close to what? To this formula format. I'm going to continue. This one cancel. So I will have d x over square root pi over x and square root x over square root pi square root minus 1. You see here right now, the square root part same as this one. Dx part here, dx over square root pi match. Only here, not good. So what I'm going to do is what? Divided by square root pi here and time by square root pi here like this. So if you do that, this one's like a 1 over this one, so I can take it out. So this part, I can take it out because it's a constant. Take it out like this. And then I do integration. Then I do integration and the d x over square root pi and the over x over square root pi, right? And the square root x over square root pi squared minus 1, like this. Now, from here you can see this one exactly the format of this one. Just say each of the x, substitute by the x over square root pi. So the final answer, this one will be what? 1 over square root pi, right? But here, instead of put it as x, we can put it x over square root pi. So that means secant x over square root pi plus c. That's the answer here, right? A secant inverse about here. So this is secant inverse here, okay? Now let's recall what we did about this one here. First thing first, we introduced the formula of this first. Means integration dx over x square root x squared minus 1 will be equals to secant inverse function of x and plus constant c, okay? And this question we're doing right now is pretty much similar format of this one, except here is the pi, but here is 1. So based on this, I'm thinking about, okay, since you have pi here, I want to get rid of the pi, change it to 1. So I have to take the factor the pi out. See here what I did here, factor pi out. If you factor pi out, you have x squared over pi minus 1, like this, right? And then to make it overall here under the variable squared, I make this one x over square root pi squared. See here? This part, I make x over square root pi as a new variable right now. So by that way, you can see you have to change what the other part of the x. Change x from here, change x from here to x over square root 2. To change x here to x over square root 2, I time both square root pi. So I time both square root pi over square root pi. This is 1, never mind. So I can take the square root pi in the front here, and this part I can keep it as what here? X over square root pi. And then, since you have another square root pi here at the bottom here, so I can cancel this too. So I will change this one to what? D x over square root pi, right? Now from here, actually from here we can get square root, this is x over square root pi, and since here only the x, I have to change the square root x over square root pi. So I make x over square root pi, but time by square root pi. So this you cancel, go back to the x as the original one here. So this part, I can take it out. So I change to this. You see here, everywhere, this is a new variable now, just like the u, huh? See u, like u here, like this. So this one exactly the same as this one, just substitute the x by the x over square root pi. So that's why the formula here, x must be by what? X over square root pi, like this. So that's why this is the answer, okay? Now, let's move on. We go to another question you raised it up. We'll be on different page here, okay? Let me get it for you. So that will be this question, number 1, because you raised up this question here. Oops. So when you have this question, right? So what are we gonna do is this here. They said number 1. Number 1, they said find the average of the value of the function f 4x cosine x squared on the interval of this, right? First thing first, we should know what's the meaning of the average of the function within the interval like this. Average formula is this. Average equals what? Average of the fx, right? Equals what? Equals to, from A to B, fx dx first, and then divided by b minus a, like this. This is the formula we're going to use. The average of the function means equals what? The function integrated within interval a to b, and then divided by the interval of b minus a, okay? So we use this formula to this situation now. We will have average equals to integration from 0 to square root pi over 2, right? And you got a 4 x cosine x squared and dx, like this. But of course, we're going to divide it by the interval, square root pi over 2 minus 0, like this, right? Now, when you have this, the key part here is do this integration. This one just constant, put it aside. We can put like this one flip. We can get a what? Square root 2 over pi like this, huh? Because at the bottom flip like this. This is the pi, okay? Now the key part is here. What I'm going to do is we do the substitution. U equals to x squared, okay? So that means du equals what? 2x and dx, right? Now, here, this is the 4x. So 4x, I can change to what? I can put a 2 outside and time by another 2 here like this, okay? So by that way, I will have, you can see here, by that way, I will have a 2x and dx. All those three parts will be what? The du. So we're gonna change this format like this. Because this one flip up already, right? So no more denominator. And then this one you have another 2 here. That's from here. And then integration and 2x dx will be the one we have du here now, right? 2x dx is du. And then this one, I will put it here, what? Cosine. It was x squared, but x squared equals to u. So I put a u here, okay? Like this. But be careful, we have to change the boundary. The boundary, when x equals 0, the u also 0. That's a 0 here. And then when x equals root pi over 2, and they get squared, will be get rid of square root, only the pi over 2, like this. So now you have 2 root 2 over pi, square root, eh? And then you time by what? Cosine integration will be equal to sine u, but the interval gotta be here 0 to pi over 2. So now you have a 2 root 2 over square root pi, and then sine, you got sine pi over 2 minus sine 0, like this. Sine 0 is 0, never mind. And then this one equals 1. So the answer will be 2 root 2 over square root pi. So that's the answer, okay? So when you do this one, generally what we need to do is, let's recall what do we have here, okay? We have this. This is the formula we need to use to apply to this question, right? And the average of, for this question, I put the fx here, this is the fx, and then dx, and then divided by the interval length, which is this. And then minus 0, never mind, I flip this part, okay? Oh, we got this. And then time by 2, and the integration from 0 to pi over 2. Because when you see, you change all the variable from x to u, so you have to square of the boundaries. So 0 squared is still 0, and the square root pi over 2 squared will be pi over 2 here. See that? And then be careful, du equals 2x dx. So it was 4, I changed to 2 times 2. And this 2, I put it outside here. And then you have another 2 times x times by dx will be du here. And then cosine x squared, change to cosine u. And then it will be easy, use the formula of cosine integration equals sine, and then put the boundary in and simplify, you can get this one. Okay? So if you have any questions, please let me know. Thank you. Bye-bye.